Okay, I want to do a little bit of review and then have you do the mid-chapter quiz. So this is problem 16 on 11.2. I had a number of questions about this, and I'm sure there were a lot more questions that none of you asked me. So I thought I'd go over it with you. Let me just read the problem to you. It says, the diagram shows the coverage of a security camera outside a building. A new security camera is installed in the same position, right here, that doubles the radius of the coverage area. So it doubles the radius here, so we're going to go out this far. How does this affect the coverage area? Well, as soon as I started looking at this, the first thing I started to think about was how perimeter and area was affected by scale factor when we were talking about similar figures. Now we were talking about similar polygons, but which I'll just throw this out there for you. I'm going to say that every single circle is similar to every single other circle. Okay, so it doesn't matter that they're not polygons; they can still be similar figures. And so let's take a look at these two circles and see how changing the radius affects the circumference and the area of the two circles. Okay, so let's begin with this one. We'll give it a radius of 3, and then this one over here we'll just double the radius up to 6. And so then, of course, I guess that means we have to think about the diameters as well. So our diameter here is 6 and our diameter here is 12. Okay, so let's look at the circumferences. So we've got our small circle over here. Circumference is diameter times pi, and so all we have to do is take its diameter times pi, and that would be the number of units that we have for the circumference. And then when we look at our big circle, okay, so I'll just do capital C here. Capital C. Again, diameter times pi is 12 times pi. Okay, so 12 times pi units here. And you can see when the radius doubles, the circumference is going to double on these two circles. Okay, but now let's take a look at the areas for a minute. Maybe we'll do these over here. Yeah, that doesn't work. So right here, area of the small one. Area is radius squared times pi. So if we come over here and we square our radius, we're going to have 3 squared times pi, or 9 times pi square units. Okay, so there's the area of our small circle. And now let's take a look at the area of our large circle. We're going to take radius squared times pi again, of the large circle. And of course 6 squared is 36 times pi square units. And you can see that with the circumference, when we double the radius, that the circumference doubles. But with area, when we double the radius, the area actually goes up by a factor of 4. Okay, so you can see 9 times pi is exactly 1/4 of 36 times pi. And that's exactly what happened in the similar polygons. When the scale factor was 2, the area increased by a factor of 4. Okay, so when the scale factor was 2, the area went up by 4 times, or a multiple of 4. When the scale factor, remember, was 3, then the area went up by a factor of 9, or 3 squared, right? When the scale factor was 4, okay, then the area went up by a factor of 16, or 4 squared, and so on. And so we just have to remember that because the formula for area is not a linear equation, it's not going to grow linearly. Okay, we're going to have a curve to this type of thing where it's going to look more like this. Okay, and it's going to grow a lot faster than just the circumference, which is going to give us this nice linear thing. So now let's think about this again. If the radius doubles, okay, so we go from 40 feet to a radius of 80 feet out here, what's going to happen with the area of the coverage? Well, it's not going to double, is it? The area is going to go up by a factor of 4. So there's the answer for that one. The next one I want to talk about, if I can find it here. Here we go. Okay, it's just how to handle some of these problems where you have pi involved, and we don't want to round things off all the time, okay? So we're supposed to find the area of the shaded part, which is kind of this little bit that's kind of left over in my perfect drawing that you see I really took a lot of time doing here. Looks like one of yours. Okay, so I got a few questions about this saying I can't do this. I can't figure out what the radius is or anything like that, and I think we can. I think we can see that if the length of this side is 10, okay, I'm going to change it and just make this a little, we'll go for it. We'll say it's 10. Then the midpoint right there's got to be 5 and 5, and that's going to make each of these radii 2.5, or maybe better, 5/2. We'll say that's the radius of each of our circles. So when we're going to find the area of this one, we're going to go, of course, 10 times 10, that's 100 square centimeters, and then we're going to subtract the area of all 4 circles, okay? And so let's just find the area of one circle, and I'm going to do fractions. I know you guys love fractions, so I'm going to take the radius squared times pi, and I'm going to say that's the area of one circle right here. So remember, we have to square the numerator and the denominator. So we have 25/4 times pi, and that's the area of one circle. And then if we multiply that number 25/4 times pi, if we multiply that number by 4, okay, which would be 4 over 1, we're going to have the area of all 4 of our circles. So let's take a look. We have 4 over 1 times 25/4 times pi. Well, I think the 4's will cancel, and we're left with simply 25 times pi. Okay, so 25 times pi square centimeters, that's the area of the circle. And it's perfectly fine with me if you give the answer 100 subtract 25 pi. We'll put that all in parentheses, so the whole thing is in square centimeters, and say that's the area of the shaded region, which is, you know, you could figure this out. This is about 78 point something, so 100 subtracts what, 78 point something with your calculator. You could give it an estimate, and you need to do that if it says, you know, give your answer to the nearest tenth or nearest 100th, something like that, or nearest 2 decimals. But if it doesn't specify, there's no reason we can't just give our answer right here. That's the exact answer. Good enough. Okay, so I want you to think about that as you do the mid-chapter quiz.